are still looking at graphical method of solving inequality problems. That is, when we get three inequality problems like this, we try to show graphically the area that satisfy that inequality. Okay, we try to show graphically the area that satisfy this inequality. We have done a lot of classes on this already. Please, you check out those classes as well, both the introductory part, so that you understand these symbols and how we use them. All right, quickly, without wasting our time, if you are given a problem like this, you are given a problem like this, and we are to show graphically the area that satisfy them. Remember, the first thing I said we do is, like if you're picking the first one, 3x minus 4y less than or equals to 16. Sorry, less than or equals to 24. And the first thing you do is you rewrite it as a linear equation. So we have 3x minus 4y equals to 24. And then I will say put x equals to 0 or y equals to 0 so that I can get the x-intercept and the y-intercept. So I will say when x is 0, realize here that this will disappear and I will have minus 4y equal to 24. And obviously, I will have y will be equals to 24 over minus 4 and y will be equals to minus 6. I will go again and come back here and say when y is equals to 0, this will disappear and I'll have 3x equals to 24. And then that means that x will be equals to 24 over 3 and then x will be equals to 8. Okay, I've got these intercepts. So the next thing I will do is to check out whether the origin will be inclusive in the solution area. Okay, in the area that satisfies the inequality, I will check whether the origin will be inclusive in it. And how I will do that is to check what is going on in the origin. You know, at the origin, x and y is 0. So I will come there and test this and see whether I will get a very good logical statement. So if I say at the origin, that means at the origin we have 3 bracket 0 minus 4 bracket 0 less than or equals to 24. Everything here will be 0. Now, is 0 less than or equals to 24? Yes. So 0 is less than or equals to 24. 0 is less than 24. But if I have something like 0 greater than or equal to 24, that's very, very wrong because 0 is not greater than 24 and 0 cannot even be equal to 24. Do you understand that now? So, but this is true. So, what does that imply? That means that the origin is part of the solution. The origin for this inequality, the origin is part of the solution. Okay, it's part of the solution. It's part of the solution or the area that satisfies the solution. Okay, the next one is this. So I will also check out what is going on here. I have 4x plus 2y less than 16. Now I'm going to rewrite it as what? Linear equation. So I have 4x plus 2y equals to 16. Then when x is equals to 0, this will go. I have 2y equals to 16. It then means y is equals to 8. Do we get that now? Okay. And then we also have when, I hope we are following what I'm doing here. I'm not too fast. We also have when, I've checked when x is 0. When y is 0, here we go. I'll have 4x equals to 16. That means x is equals to 4. When you divide both sides by 4. Do you get? So 16 divided by 4 is 4. X is 4. But we'll also check what is going on at the origin, whether the origin is going to be part of the solution area that satisfies this inequality. So the origin, at the origin, you will realize that 4 into 0 plus 2 into 0 less than 16 is 0 less than 16. Is 0 less than 16? Yes, 0 is less than 16. So the origin is part. Okay, the origin is part of the solution. So, and then this one, we don't need to do any solving. The x is greater than or equals to 1. We can quickly show that all these, you can bring them together now and show them on a graph. Okay, let's have our graph on the Cartesian plane. So you can show these values and then map out the area that satisfy that inequality. So we start taking out these points. On this first one, x is 8, x being 8. So let me assume that somewhere here is 8. Okay, I don't think there's any other x that is within 8. I saw x over there again, that is 4. This is somewhere here 4. And then y, what about y? Y here minus 6. Y here minus 6. What about the other y? The y of the other side is 8. Okay, let's assume here 8 and here minus 6. Okay, so for this one, x is 8, x is 8, and y is minus 6. So I will join this one. Remember, we are going to use, is it thick line or dotted lines? Is it thick line or dotted lines? This should tell us that it is thick line. Okay, so we will use thick line to join this. Now, what did we say about the area that satisfies the inequality? Whether the origin is inclusive. We said the origin is part of the solution. So I am going to shade the origin inclusively. The origin inclusively as part of the area that satisfies the inequality. Okay, I may still come back to that. Then what about the other side? y8, y8, x is 4, x is 4, and we are using, because of this, dotted line. We are using dotted line. Dotted line. We are using dotted line to demarcate the area that satisfies the inequality and the area that does not satisfy it. Now, in this case, did you also say what? You said also 0 less than 16. The origin is also part of the area that satisfies the inequality. So we are shading inclusively the origin. We are shading inclusively the origin. Inclusively the origin. As we are doing this now, you will be checking why I use these 3 different colors of the marker is so that you can be able to point out quickly where the 3 shadings appear. Even if you use pencil in a graph, your pencil should capture the shading should capture. You check out for the area where the 3 shadings, the shadings for the 3 inequalities or 4 inequalities or 2 inequalities, where the shadings you did, all of them appeared in that area. That's the area that satisfies the inequality. So you can see it is already, the picture is already coming out. It's not here. It's not here. Do you get it? It's not here and it is not here. So it's within here. Now let's put up the other last. Okay. You know this one. This one is 4x plus 2y equals to 16, and this one is 3x minus 3x minus 4y equals to 24. Okay, and then finally the last one we have is x is greater than or equals to 1. Somewhere here, where are we going to put 1? Let's somewhere here be 1. and x is greater than or equal to 1, that means we are using thick line to demarcate it. You see, this line will be standing straight. Do you see the difference between this one and the other ones? This line will be standing straight. And you can see that the area that is greater than or equal to 1 is this way. And we are shading that direction. We are shading that direction. We are shading that direction. Okay. Finally, did you notice the place where the 3 shadings appear? Did you notice it inside this triangle? Let me label it. Let me label it. Let me make this so that you can see clearly where the 3 shadings appear. Did you notice it now? Okay. So that place where the 3 shadings appear is the area that satisfies the inequality. Is the area. Look at it here. Look at it here. It is labeled A, B, C. You now explain the area A, B, C contain the solution that satisfy the inequality. Okay, so we are heading close to what we call Go programming, and God help us, we might go into that and also look at it. All right, I am trusting God that the explanation I gave here was able to explain in detail everything you need to understand about how to show graphically the area that satisfies a given inequality problem. All right, thank you so much for being part of the class. Please send this video to someone, okay, that it can help. Like our video and subscribe by clicking on the subscription button down there, and partner with us in any way, to promote what we are doing. Our email is down there, and as you do that, God will